Here we're looking at a picture of Poseidon. Poseidon was the Greek god of the sea, and so the reason I have Poseidon up here is because Poseidon, being the Greek god of the water, water is something called a covalent compound. The reason it is covalent is because it is made primarily of two nonmetals. And when you have two nonmetals bonding together, typically you have what's called the covalent bond, or the sharing of electrons. So we're going to look at that through these next few slides. Quick recap. Remember, our valence electrons are identified by the group number of the representative elements, and they are also the number of electrons on the outer shell of an atom. The maximum number you can have is 8, and the Lewis structure is where we combine the chemical symbol with the number of valence electrons. When we are sharing electrons, we are creating a bond between two lone electrons of two atoms. So what I mean by that is if we look at these guys, we have hydrogen over here, we have hydrogen over here. Now, some of you might be wondering why this electron right here is on the left when I have you draw it on the right. Don't worry, this picture is just showing an attraction between the two lonely electrons. Well, if we think about our metaphor yesterday about middle schoolers dating and how they're always trying to date to pair up and become more stable, that's exactly why elements bond. So this guy is lonely as well as this guy. And so what we're going to do is we are going to draw a line between these two lone electrons to show that they are sharing the same space together. They are bonding. So if we zoom out a little bit, we look over here and see that these electrons are now on top of each other. There's a variety of ways in which you can demonstrate covalent bonding. I'm going to show them to you throughout the slides. This is one of them, where if we take, let's say we're doing, well, let's just stick with two hydrogens. Hydrogen here and hydrogen here. Well, it kind of helps if you do a step-by-step process. So first you identify your lone electrons. There's one there, there's one there. You can, A, draw a line between them. So the finished demonstration would be this. Or you could do a scenario like this where we take the lone electrons and we put them on top of each other, like we have here. That shows that they are sharing the same space, and thus it is a covalent bond. In another type of bonding called ionic bonding, electrons are actually given and taken from atoms, which is demonstrated differently. So the fact is that the way you choose to demonstrate this actually does matter. If we, oh, by the way, here's our man, Phil Collins. You guys might not know who he is. He was a drummer in the 70s and one of my favorites. But guy's a goon, and I know this is kind of disgusting, but you gotta make sure you share in covalent bonding. Don't forget that, or Phil's gonna come find you. Okay, so there's 3 types of bonds. So what we did up here is we have one pair of electrons being shared. That means it's a single covalent bond. Well, what happens if we have more than one pair of electrons? So if we look at this guy, here's what's actually going on here. We're going to highlight this chemical symbol. And how many valence electrons does carbon have? So let's do a Lewis structure for carbon. We're going to do one on the right, one on the left. So we have our 2 Lewis structures. Carbon has 4 valence electrons, which means that it can bond in 4 spots. So if we zoom in even more, well, it looks like it's not going to go anymore. Let's go ahead and draw our electrons. It's not going to go. All right. 1, 2, 3, 4. 1, 2, 3, and 4. And I'm going to get rid of this phantom guy right there. So we see our 4 electrons, however, they are not in the configuration that we've shown above. The reason is we've moved those around so they can rearrange and bond to each other. Well, in this case, we have 2 pairs of electrons being shared between these 2 carbons. That is called a double bond. The double bond is shown like this. And the fact is, the reason I have this picture here is because this is actually a picture of an unsaturated fat molecule. Unsaturated fats have a spot where there is at least one double bond. If there's one double bond in the molecule, it causes the fat chain to bend. And if we think about it this way, what's the big deal? Well, if we have olive oil is liquid at room temperature, but it contains 14 grams of fat per serving, just like coconut oil. But coconut oil is usually a solid at room temperature. So the reason that's the case is because the olive oil molecule chains like to bend, and when they bend, they can't really stack up on top of each other. Well, coconut oil has a lot of that fat being saturated. So if it's saturated with hydrogens, which means it kind of makes the chain like a brick. And so if we think about it that way, these bricks can just stack up onto each other and make a solid structure. So that is the reason why olive oil and other certain fats, certain oils that is, are liquid at room temperature. It's because of those spots of unsaturation, those spots of double bonds. If there's one double bond, it is called a monounsaturated fat. So if you look at a food label, you'll see this. If you have more than one double bond, it is called polyunsaturated. Triple bonds are where we share 3 pairs of electrons. So a prime example is if we take 2 nitrogen atoms. So let's highlight our Lewis structure. Again, these electrons are in slightly different configurations. That's okay for now. Let's figure out how we got here. If we draw our 2 Lewis structures, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. First, we got to identify how many lone electrons we are sharing. So we have 1, 2, 3. 1, 2, and 3. The next step is we want to pair them up with one. We want to pair them up between the 2 atoms. So this lonely guy is going to go with that one. This guy is going to go with that one. And this guy is going to go with that one. So if we look at that, it's kind of messy. Well, we've drawn 3 lines, so now let's just rearrange the electrons. The easiest way to do that is to remember that the bond should be occurring between the chemical symbols. Bonding occurs between. Remember that, bonding between. So in that case, these electrons that are already paired up are going to then go to the outside. So if we rearrange, we put our paired ones on the outside, like we said, and all the bonding ones between. So 1, 2, 3, and done. This may be kind of confusing to get used to. It's okay. If you keep practicing, it'll come more naturally as the next few days pass. So, like I said earlier, covalent bonds can be drawn a number of ways. We're just going to focus on the electron dot diagram, which is what we've been doing the whole time, where we take Lewis structures of multiple atoms and draw lines and connect the dots. So if we do H2O, let's practice. So right now, this is our first time doing a bond between 2 different atoms. So if we do hydrogen, and another hydrogen, because our formula, okay, the combination of these elements, say we have 2 hydrogens. How many oxygens do we have? Well, there's no subscripts, so it's just 1. So if we go to our diagram, let's draw an oxygen. Okay, step 1, draw our Lewis structures. Step 2, we need to figure out our lone electrons. So we're going to circle these guys. One, two, 3, and 4. Well, the deal is that these guys want to pair up together. And what we're going to do is try to create um, a total number of 8 shared electrons around our central atom. Our central atom is going to be oxygen. So this rule where we try to get 8 around the central atom is called the octet rule. Like I said, the maximum number of valence electrons we can have around an atom is 8. And so this is these multiple atoms trying to become more stable. So we're going to draw a line between them. There's a line, and there's a line. So now, let's simplify it and rearrange. Move up. We have oxygen and our hydrogens right there. We have our pairing electrons, or bonding electrons, shown right there. And then, where do our lone pair electrons, or our paired electrons go around the oxygen? Well, we can just put them like this for now. Now, you can if you do it like this, where it's more linear, that's fine. The fact is, oxygen is actually tilted like this, or excuse me, water is actually tilted like this, but that's more high school stuff, so no worries about it. And here's our example. So, again, always start with drawing your Lewis structures. Then circle your lonely electrons and connect the dots. And then, there you go. Now remember, you can also draw these shared like this. So if we have our oxygen and we have our hydrogen shown in a different color, let's do them in red. You can put the electrons over each other like that to show that they're being shared. That is okay. However, if you choose to do that, what I would recommend is that you circle. So, because most of the time you're not going to have 2 different colors of ink, so that shows that they are sharing that pair of electrons between 2 different atoms. Now, since we're bonding multiple atoms together, we can do that in 2 classifications. This can confuse people, so what we're going to do is deal with a molecule first. Molecule has to have 2 or more atoms joined together. It doesn't matter if they're the same or different elements. So therefore, anything with more than 2 atoms in it is a molecule. Now, what's a compound? Compounds have to have 2 different elements involved. So let's look at what that means. If we look at CCl4, we have a carbon and we have a chlorine. Carbon is not chlorine. Those are 2 different elements. Since they are 2 different elements and bonded together, they are called a compound. A good way to remember this is that a compound word is made of 2 words that are different and that are joined together. For example, if we have backyard, that is a compound word of 2 different words. A compound word is not back. It is not yard. It is 2 different words. So chemical compounds are exactly the same thing, where they have to have 2 different elements involved. Now, to have 2 different elements, how many atoms do we have to have? Well, we have to have at least 2 atoms if we have 2 different elements involved. That said, remember that if we're talking about a molecule, it's anything formed between more than 1 atom. So that means that all compounds, being that all compounds must have at least 2 atoms in them to have 2 different elements, all compounds are molecules. But not all molecules are compounds, because a molecule could be H2, it could be N2, it could be O2, and what you're seeing is you have 2 atoms, but they're the same element. If you have one of these are only molecules. Electronegativity, we're not going to worry about that today, and then we'll also talk about polar and nonpolar on another time. So we're going to stop there for today and do some practice.